You are watching TFI.
Greetings! I didn't know you were still making Inventor videos, boy. Yeah, I know what you're going to do. Cautionary tale coming at you today. This is something that I've fabricated, but it's something that I've seen quite a lot in the past, and I thought it's worth mentioning because I can imagine quite a few people come a cropper with this one. And it's something that you might not be aware of, but there'll be plenty of people who are. There always is, man. But what I've got here is a native Inventor assembly of around 404 parts with 2,800 copies and patterns and whatnot and occurrences. And it's been placed into a sub-assembly, so it's, there it is. And what we'll tend to do is you'll then design stuff around this, whether it be a chassis or a control panel or hydraulics or whatever else. Fine, mate, fine. So that's what we've got. Currently, the Inventor process itself is using 2 gig of RAM, which is not bad, mate, given that there's 2,800 occurrences in here. So that's pretty reasonable. That's pretty reasonable for a decent enough sized assembly. And that's that. Right, so what am I talking about? What's the issue here? Right, well, what we've all been conditioned to believe, and in many cases trained to believe as well, is that it's always beneficial to shrink wrap your data if you're using it somewhere else, or derive it if you're using it somewhere else. And what I mean by that is, say for example, you are going to design the chassis that goes above this vehicle, for example. If you're going to design the chassis, you're going to need the mounting points in that chassis assembly. It's kind of natural, and it goes with your training to think, right, well, I need to place this track's assembly into my chassis assembly to use as mounting points. There's lots of other ways of doing that, but in a collaborative multi-user environment where not you don't have exclusive ownership of this one assembly to edit it, other people need to get at it. What people tend to do is place this into their higher level assembly to use as reference. And rather than hang 404 or 2,800 parts into their other assembly just purely for the purposes of reference, they'll shrink wrap it down into a single part to use as reference. Fine. What's wrong with that? Well, all kinds of things, mate. So I've done that. I've taken a shrink wrap of these tracks, and I'm going to show you what happens when I place that into my high level assembly to use as reference. So I'm going to start up a brand new Inventor assembly. After now I've finished waffling for a good half hour. Bit of an exaggeration, mate, but right, tracks shrink wrap, there it is. That's the IPT. So I've wedged all of the parts from this track assembly into here to use as reference. Nice lightweight single IPT just floating around on its own. It's just this nice manageable entity that I can use as reference in not just my chassis, but also my hydraulic assembly and the electrical assembly, tubing and piping, everything else that goes around with it. And I can use this one IPT. So let's place it in, and we'll let it think away. I'll pick it up once it's done. There it is, right click, place and ground at the origin. In it goes, right click and OK, right click on the node, set that as reference, and there it is, my little lightweight IPTs in here, ready to be used as a point of reference for designing stuff around it. Neil, what's your point? What's the problem here? Right, well, let's take a look at the Inventor session now, mate. It's using 11.5 gig of RAM for this. It's got 2 files open in session, the assembly and the part, 1 document, the part, and we're using 11.5 gig of RAM. And as soon as I start doing stuff, zooming in, looking at detail, that's going to start shooting up. To see my point? If you've got this system that I'm on right now, this workstation has 32 gig of RAM, and I'm using 63% of it, and I've got barely anything else open. If you've got a 16 gig of RAM system, which a lot of people do, you're stuffed, mate. You're absolutely stuffed at this point. And I haven't even started putting in any actual data in, plates and stuff for the chassis of the vehicle. I've well stuffed myself. I'm using like 6 times as much RAM as I was using with the original assembly. And all along, I've been conditioned to believe that this was the more effective and efficient workflow. Not the case, though, mate, is it? Now, why is this happened? Why is using the shrink-wrapped part as opposed to the huge heavy assembly less efficient? Well, that's all to do with how you create your shrink wrap, mate, because the shrink wrap itself, the IPT, that lightweight IPT, is 1 gigabyte in size. That's a 1 gigabyte part file. And I've had it confirmed by someone, I can't remember who, but someone on the Inventor development team. The IPT file format, and this won't be just for Inventor, this will be for any CAD system. The single part format is never ever designed to host this much data. We've got an absolute massive colossal assembly worth of data wedged into a single part file. It's not supposed to be that way. Although Inventor can bring it in, it has a hugely hard time in handling it. So once you've placed this in as a reference part and you've designed your assembly around it, and the assembly grows and grows and grows, you might even have referenced this IPT into other assemblies, not just your chassis, you might, or different other areas of the vehicle. You get an unusable top level assembly, and it's contributed hugely towards that, this shrink wrap file. So the solution to getting around this and to fixing this, mate, is if you need to create a shrink wrap of these tracks to use as reference, for example, I know there's very few people out there who'll use this, but it could be, thinking of your use case and what you would do. You might only need sort of that hole there and maybe these holes here. All of this data here is completely pointless. It doesn't even need to be in the shrink wrap. So when you create your shrink wrap, exclude all of the parts that you don't need and only include the stuff that you do. And that seems like a pretty simple, straightforward solution. But if you didn't know there was a problem in the first place, you might not have considered that, and you might be ending up with issues like this. So as a general rule of thumb, this is possibly the goalposts will change with this. It might not be as black and white as this, but 1 gigabyte is obviously clearly far too big for an IPT. You want to be aiming at ideally no bigger than 50 megabytes. Like that's how far off this is. Anything over 100 megabytes is going to be causing problems all day long. So sort of between 50 and 100 is at max where you want to be with the size of your shrink wrap and derived parts. So there you go. That's a cautionary tale. 1 part opening session, and I'm using 12.5 gig of RAM. It's mental, mate. It's mental. So this is an issue which I've seen in a lot of companies, and it's something that you're just trained to believe is okay, just creating shrink wraps of stuff. But you're supposed to remove detail, and I'm not sure how strongly that's emphasized, but there you go, in your face. That's why it needs emphasized, because that's just crackers on every level. All right, mate, that's all I've got for this one. I just wanted to show you that, just with a bit of evidence, mate, as to how shrink wraps aren't always the savior of large assemblies. You've got things like levels of detail and stuff as well for managing large assemblies, but this shrink wrap wasn't done for the sake of managing a large assembly. It was to create a reference part. But yeah, anyway, mate, there you go. I'll leave it there, and I'll see you in the next one. Toodles.